Hello students, in today's video, let us learn about fusion energy. Fusion energy is another renewable energy source. I hope that you know about the nuclear reaction, the nuclear fusion process. So in this process we know two lighter nuclei comes together to form a heavier one, and in this process a huge amount of energy is released. This energy is called fusion energy. And where does this energy come from? This energy is actually coming from the mass defect that is involved in this process. So we know the end product of this nuclear fusion does not have as much mass as the initial ingredients, and the mass that is getting lost in this process is called mass defect. This mass will be converted into energy according to the Einstein's relation E equal to mc square. This energy will be released in a nuclear fusion process. So normally in a fusion reactor, we maintain this fusion process in a controlled manner to release huge amount of energy. There are different fusion reactions. For example, isotopes of hydrogen can undergo nuclear fusion. For example, deuterium. What are the isotopes of hydrogen? We have 1H1, which is the hydrogen, and we have 1H2, which is the deuterium. Then we have 1H3, which is the tritium. So there are several fusion processes that are possible with hydrogen atoms itself. So one such reaction is called DD reaction, where deuterium and deuterium fuses together. Another reaction is deuterium-tritium reaction, where a deuterium nuclei and a tritium nuclei reacts together. Normally, in a fusion reactor, we prefer DT reactions, the deuterium-tritium reactions, because they can be maintained at a lower temperature and they also release huge amount of energy. So as we know, in a DT reaction, deuterium-tritium reaction, the initial ingredients are deuterium and tritium. In a deuterium, we have one proton and a neutron in the nucleus. In a tritium is 1H3, so it has one proton and two neutrons. Both are isotopes of hydrogen. So they will fuse together according to the equation deuterium plus tritium, finally giving a helium nucleus and releasing a neutron. And in this single process, 17.6 mega electron volt of energy will be released as the final product, as a final release. This energy can be harnessed and used in a fusion reactor. So how does this deuterium and tritium can be obtained? So they can be easily found from the nature. Deuterium is available from seawater. If we take 6,700 hydrogen atoms, out of this one will be deuterium if we are considering seawater. Similarly, tritium can be easily produced by bombarding lithium ions with neutron. So lithium plus neutron will finally yield you the tritium atoms. So this deuterium and tritium thus obtained can be made into nuclear fusion, releasing huge amount of energy. So as we see, the final product is helium and neutron, and the final products are not radioactive or toxic or this is not a greenhouse gas either. So as we can see here, this kind of DT reaction are eco-friendly and produce least amount of pollutants as byproduct. And another challenge that we face when we come into the nuclear fusion process is how we could maintain this reaction. The nuclear fusion process is often called thermonuclear reaction because this process will happen only at very high temperature. As we know, in a fusion process, two nuclei has to come together and fuse. So both the nuclei have positive charge, and as they come closer, there will be very high Coulomb repulsion between these two nuclei. So in order to overcome that, the energy that is maintained in a fusion reactor should be very high, and hence the temperature should be very high. So we know at such large temperatures, materials and gases exist like plasma. it is almost impossible to maintain plasma within a solid container. The plasma will melt the container and will leak out. So it is very difficult to keep this plasma at very high temperature in order to maintain nuclear fusion process. So one of the innovative techniques that we use is magnetic confinement to store this plasma, which is undergoing nuclear fusion. So in order to contain using magnetic field, we are neither contacting the plasma, it is being held by the magnetic forces. Often we use toroidal tokamak as indicated in this picture. Toroid will be maintained. We know inside a toroid we have magnetic field, and the magnetic field will be used to confine the plasma inside without touching it, actually touching it. So this is one of the major challenges that we face in maintaining a nuclear fusion reactor, to set up such a magnetic confinement system where plasma can be maintained. So even then, as we have seen, there are plenty of advantages for a fusion reactor, such as the availability of raw materials and its potential to produce large amount of energy. So it is said that from 50 cups of seawater, the deuterium obtained from 50 cups of seawater is enough to replace about 2 tons of coal. So that much simplicity and easiness is brought by a fusion reactor, and their byproducts are relatively stable and they are not greenhouse gases, thus giving a huge boost to the environment and its protection. And its main disadvantages, as we have seen, is maintaining the nuclear reactor and the financial requirements of building these kinds of magnetic field containment systems. So I hope this setup of nuclear fusion reactor is clear for you, and the fusion energy concept is clear for you. Thank you.